In this video, we're going to talk about the effective rate, or the annual percentage yield, when we're dealing with compound interest. Now, the easiest way to think about this is to go back to our example that we had near the beginning here. When we talked about putting $1,000 into a bank account, getting 8% interest. If you just kind of think this through in your head, you might think, oh yeah, I get $1,080 at the end of the year. Okay, I'm adding 8%. But that would be if you're just getting simple interest, or if you're compounding one time that year. But if you compound more than once, then notice you end up with more than 1,080. In fact, it's almost like you gained more than 8%. Okay, when we compounded twice, we ended up with $1,081.60, which basically means we gained 8.16%. So instead of just gaining 8%, we gained more than 8%, 8.16%. So this is the effective rate, or the annual percentage yield. Now, the effective rate is always going to be higher than if you compound more, at least once per year, more than once per year, the effective rate will always be higher than what's called the stated rate, or the nominal rate, which would be the 8%. Okay, so let's go down and talk about how we calculate the effective rate, the annual percentage yield. Okay, so it says the effective rate, or the annual percentage yield, corresponding to a stated rate of interest R, compounded m times per year is, well, this effective rate is equal to 1 plus R over m to the mth power, then minus 1. Okay, and one thing I want to point out is that some of the problems will say nominal rate, some of them will say stated rate. That means the same thing. That kind of corresponds to the 8% for the problem that we were just looking at. Okay, that's the nominal rate, or the stated rate. Okay, but what we're trying to find is the effective rate, or the APY. So let's look at this example. Find the APY corresponding to the following nominal rate, 5% compounded monthly. Okay, what's the effective rate, or what's the APY for this? Now, we expect our answer to be bigger than 5%. Okay, so what's it going to be? We have 1 plus R over m, but R is 0.05. Now, the m, remember, is the number of times you're compounding in a year. So this would be 12. Okay, we're compounding monthly, it would be 12. And so there's a 12 also up here because of that m. And then subtract 1. Okay, and we'll need to work this on our calculator. So what we do is we type in parenthesis 1 plus 0.05 divided by 12. Now, you could have done the 0.05 divided by 12 ahead of time and simplified it, and then just do 1 plus that, and then raise to the 12th power. And before I subtract the 1, let me just put this here. We have 1.051161898. Now we have to subtract 1, and what do we get? We get 0.051161. Okay, 0.051161. And there are a few more decimal places here. 8979. Okay, 8979. Okay, so what does that mean? Well, basically, as a percent, this would be 5.1618979%. Okay, that's the effective rate corresponding to the stated rate, or the nominal rate, of 5%. Now, a lot of times they'll say round your answer to maybe 2 decimal places, or to the hundredths place. So this would be 5.12. Okay, so we put our answer as 5.12 if we were rounding to 2 decimal places. We have to round up, right, because 6 is bigger than 5. Okay, now let's do another problem. It says Bank 1 offered a 2-year certificate of deposit, CD, at 3.47% compounded quarterly. On the same day, First Bank offered a 2-year CD at 3.45% compounded daily. Find the APY for each CD, and which bank paid a higher APY. Now, first of all, we have to talk about what's a certificate of deposit. Okay, a certificate of deposit, basically, when you take out a certificate of deposit, it usually has a time period associated with it. Maybe it's 2 years, or 5 years, or 10 years, but it's kind of like you're putting money into a savings account, but you get a higher percentage than what you would normally get in a normal savings account. The one disadvantage for you is that you're not allowed to take your money out until the end of the 2 years, or 5 years, or whatever. Okay, well, most of them do allow you to take your money out, but you have to pay a penalty. Okay, so you can kind of think of it as you're sort of putting in a savings account, but you're not allowed to really take it out until the end of the time period. So you get a better interest rate. Okay, so we're going to compare CDs. By the way, you can just go and get one of these at a bank if you want to. Right now the interest rates are pretty low, at least when I'm making this video, they're pretty low. But anyways, which of these banks offer the better CD in some sense? You might think, well, it's got to be this one, the bank one, because they're offering 3.47%. Okay, and this one's only offering 3.45%. But notice this one is compounded daily. Okay, whereas the 3.47 is only compounded quarterly. So which one ends up giving you the better, more money, essentially? Which one has the better APY, annual percentage yield? Okay, so we have to plug these into our formula. Okay, so let's go first of all with the bank one. Okay, and remember our formula is 1 plus R over M to the M minus 1. So if we plug things in here, we'd have 1 plus, and then the R is 0.0347 divided by, now it's compounded quarterly, so we're dividing by 4, raised to the 4th power, and then minus 1. Okay, so let's figure out what this is. So let's go back up to our calculator. I guess we can move it over here. We have, first of all, parenthesis 1. Okay, you can't see that very well, can you? 1 plus 0.0347, okay, over 4, raised to the 4th power, okay, you can see it here, and then bring it out here, put the minus, okay, minus 1 right here. Okay, make sure you don't have the minus 1 up there with the 4. Okay, when we work this out, we get 0.03515. Okay, so 0.035154. 0.03515, etc. Okay, a couple more decimal places. 0.03515, 1508. Okay, 508. Okay, so basically 3.5154%. Okay, approximately. Okay, rounding to 4 decimal places. Okay, for the other one, for First Bank, okay, we have the same formula, only this time, so let's rewrite the formula. Okay, only this time we have 1 plus, it's 0.0345, but it's divided by 365. So let's assume that we have 365 days in a year. Okay, and then we'll subtract 1. So let's see if we get a similar rate here. We'll see if it's a better rate or a worse rate than the previous one. So we have 1 plus, okay, you can see this a little bit better here, 0.0345, okay, divided by 365, okay, and all raised, okay, and the parenthesis first, and then all raised to the 365th power, 365. And make sure we go down here before we subtract our 1, minus the 1. And what do we get? Okay, it says 0.0351003. Okay, so 0.0351 00, and let's keep looking here, 0.0351003408. Okay, 3408. So what is that as a percentage? Well, it'd be 3.5100%, right? So we're rounding to 4 decimal places again. Notice that the APY for this first one was higher than the APY here, even though the it actually did end up being higher. This was 3.47%, and this was 3.45%. And I was wondering which one would be better. Would the 3.45 compounded daily be better, or the 3.47 compounded quarterly? And I generally wasn't really sure. But it turns out the 3.47 one is just slightly better. Okay, just slightly better than the one that was 3.45. Now that's not always the case. For sometimes, since we're compounding more often, okay, compounding daily as opposed to compounding quarterly, this APY could get pushed up higher than this one. Okay, it very well could be. In fact, I think maybe one or two of the homework problems we have to do something like this. This actually does get pushed up higher. The APY for the smaller rate gets pushed higher than this one. But in this case, it is the 3.47 that gives the higher APY. So bank 1 has the better rate.